Yes, good evening guys to all of you. Please tell me, am I properly audible and visible to all of you or not? Yes guys, please tell me, am I properly audible and visible to all of you or not? So guys, this is the session for formula revision for machine design. And like you know, in the marathon, we have already seen the machine design subject. Yes. Sorry for the lag guys. Now please tell me, am I properly audible, visible? Actually there was a problem with the device. I feel now everybody is able to watch me properly. Is it clear? Shubhrato, Sanjay, Ishwar, voice is coming properly. Audio, video clear, please tell me. Okay guys. So now without wasting the time, we are starting the session. And guys, this is some detail about me, those who are watching me for the first time. And guys, you can download the app, BYJU'S exam prep app. There you can get a lot of free stuff available. Okay, so these are the vision courses. They are starting for gate 25 and gate 26. And there is a very important announcement before we start the session, that these are the 2 days, 25th January and 26th of January, where you can get straight away 50% off in the BYJU'S exam prep courses, and you can use the code Republic50 to get that discount. This is the number you can call on that. Okay, and for these 2 days you are going to have this discount. It is available on both the subscription for 25 and 26 both. Okay, so this is a wonderful thing you can get on this Republic Day. Good evening Ashray. So now we are starting the session guys. This is a wonderful series coming on the app. In this series we are majorly concentrating on maths and aptitude, because everybody know mathematics and aptitude are going to play a very important role in the gate preparation. So guys, like you know, I am taking mathematics on YouTube for you guys, and I am taking with concept plus 1-2 problem, but we are not going for a specific practice session. So for that reason, on 26th of January, okay, on 26th of January there are 2 sessions. One would be at 11 AM, that would be taken by Richa Gupta ma'am, and second would be at 6 PM, would be taken by me. And in these 2 sessions we are going to do total 75 plus questions. Okay, that is on the occasion of this Republic Day. So these 2 sessions you do not forget. And after that, on 27th, Abhinav Negi sir would be telling you at 5:30 PM how to optimize your preparation in this last minute. Okay, and then as many students requested, sir कि last 3 years के question बहुत interesting थे, कुछ मुश्किल भी थे, तो वो करा दीजिए. So for that, Rakesh sir and me, we are going to take, Rakesh sir would be taking at 11 AM on 29th of January. He would be taking last 3 years PYQs of aptitude, and I would be taking at 6 PM PYQs of mathematics. So these 4 days, you can say 5 days, are going to give you a lot about mathematics and aptitude. So this is important for all of you. Don't miss this opportunity. And just we are starting the session, don't worry. 1-2 more things. From 27th of January you can appear for this last mega mock challenge. And then guys, this is the formula revision series going on. Today we have machine design session. After that you are going to have fluid mechanics, production, industrial, and tone and vibration. And this is the schedule for maths and aptitude series. Here some changes have been happened. We have already completed matrices, we have already completed differential equation. Now calculus will be coming on this upcoming days, 27, 29, because now every day one session would be there for mathematics. Yes, now we are starting. This is the last thing. Civil versus mechanical war is going on, and already 4 sessions are over. This up to this is over. Tomorrow principal stresses I would be taking on 26th of January. So along with the mathematics session, you are also having the civil versus mechanical war, where 3 students would be getting 2100 rupees total price. Okay, now my dear, I feel all these ads are over, but they are required because they are the things I need to communicate to you. This is the Telegram channel link where you will get the PDF of today's session. Mathematics PDF you did not get because I took that from office and some problem happened in annotation, but I have arranged the annotation PDF. Don't worry, I will share with you after this session. Now we are going to start with the basics. So as I already told you, this session is clearly going for only formulas. Okay, so we would be concentrating on the formulas which are going to be required, but I will be starting from first to end. Every chapter I will be covering. So first of all, basic formulas are those which are required from strength of material. Like, you know, whenever we have a member, on this member, if we are going to have a force acting like that, you know, because of this P, the stresses induced are nothing but P by A. That you know from strength of material, yes or no? Then my dear, let us say if we are having the same bar or beam, let us say it is subjected to some bending moment M. You know that because of that the stresses induced, we are writing it as, it is going to be M into Y upon INA, and this is coming from the equation of bending equation. You can say pure bending equation, which is nothing but M upon INA. Okay, then it is equals to sigma B by Y is equals to E by R. Using this you can find out the stresses on any fiber which is there in the member. On any fiber we can find out stresses. Faninder, good evening. On any fiber which is, let us say, at a distance of Y. So if you want to find out the stress at a Y distance, okay, if you want to find out the stress at a distance of Y, like if I show this cross section, then you know this is said to be neutral axis. So if you want to find out the stresses on a fiber which is Y distance above or below from this neutral axis, then the formula applicable for this is going to be this. And if radius of neutral fiber is known, then the bending stress formula will be written as E into Y by R. So there are two formulas, one is My upon INA, second is Ey by R. Everybody know we use this formula whenever normally we want to find out the stress at any fiber. This formula is used whenever we are aware of radius of neutral fiber. Okay, so I am giving you all the formulas, don't worry. And guys, whenever we are talking about a shaft which is subjected to the pure torsion, a shaft which is subjected to the pure torsion like this, you know we are going to have the formula for that whenever we are having the equation T by J is equals to tau S by R. Everybody is okay with this, na? Everybody, because formula revision means what? Here those students are there who have already studied the SOM. So they just want to see all the formula once at one glance, okay, in one shot. So if you see this, you can write the shear stress at any fiber is nothing but T R by J. And if you are interested in the maximum shear stress, my dear, then it is going to be T into maximum radius by J. Is it clear for everyone? Please tell me. Faninder, mechanical engineer, Ashray, Ishwar, Shubhrato, Sanjay, please tell me, am I clearly audible, visible, everything is fine? So this is going to be the formula. This is for at any radius, this is for the maximum radius. If you see the shear stress distribution, as shear means parallel to the cross section. So if this is the torque acting, then you know the shear stress distribution can be seen like that. 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 This would be the maximum, this is the stress distribution, and this is going to be the maximum stresses at the outer fiber. Okay, so guys, now this is the formula for the shear stress. Okay, this is the formula for the bending stress, and this is the formula for the normal stress coming because of force. If the force is compressive, you would be saying plus minus, plus for tension, minus for compression. नहीं आश्रय बस हो गया सिर्फ फॉर्मूला ही बताने थे. Okay, now the last one, you know that whenever we are talking about the principal stresses formula which would be required for theory of failure, that is nothing but sigma xx plus sigma yy by 2 plus minus square root of, it is going to be sigma xx minus sigma yy by 2 का whole square plus tau xy का whole square. This is the formula for the principal stresses which is required for the theory of failure topic. Okay, so now my dear, we have this formula as well. Now the last formula is for bearing stresses. Whenever we would be having the bearing stresses, or let us say the crushing stresses. So these two types of stresses whenever you would be having, for them the formula is very simple. For that you would be saying the bearing stress or crushing stress. It is written as load by projected area. So when I would be teaching you bearing and when I would be teaching you joint, there we will see what is the projected area. And I can also tell you, if we are having a cylinder, then projected area would be a rectangle like that. And whenever we have a sphere, then this is going to have a circle. So this is what is the projected area. Okay guys, so with this we have seen all the formulas which would be required. Now we are entering into the theories of failures. So when we are talking about theories of failure, the very first formula which comes into picture is the factor of safety. Factor of safety is written as failure stress divided by permissible stress. This is the very first formula. And in that we are going to provide some reserve strength to the material, that is given as the failure stress, and it is going to be minus permissible stress. I would also like to tell you that this permissible stress is also known as allowable stress. This failure stress may be SYT for ductile material. It may be SUT for brittle material. So depending on the type of material, the failure stress would be changing. Okay. Phaninder, within 1 hour we will complete. Within 1 hour, you can see now fastly the things will be coming. I would just write, it is formula revision, so I am not going to teach any other thing other than formula. So very first theory you have studied here is maximum principal stress theory. You know, maximum principal stress theory says sigma 1 or sigma 2 is going to be less than equals to SYT or SUT by N. This is the formula for MPST, maximum principal stress theory. Then my dear, if we are going to talk about the second, but before we go to the second theory, you need to know where it is applicable. It is applicable for brittle materials. It is applicable for brittle materials for all the loading condition. For all the loading condition. The best part about this session is whatever I am writing on the slides, you would be getting this PDF and this will be helping you in formula revision very nicely. Okay, so this is going to be the formula for maximum principal stress theory. Now we are going to have the second theory as maximum shear stress theory. Okay, everybody know maximum principal stress theory was given by Sir Rankine. So that is also known as the Rankine theory. Okay, similarly when we are talking about the MSST, that theory was given by Sir Guest and Tresca. So we also call it as Guest and Tresca theory. Majorly it is known with the name of Tresca theory. So when we are talking about this, it is giving two statements. It is giving two statements. What are those? First statement, it is giving for same nature of principal stresses. For same nature of principal stresses. If both the principal stresses are either tensile or compressive, then the formula is sigma 1 or sigma 2 is less than equals to SYT divided by N. This is going to be the formula. And guys, if we are having the second case, that is for opposite nature. That is for opposite nature. That is for opposite nature. For that, the formula will be sigma 1 minus sigma 2 is less than equals to SYT by N. When I am writing SYT, it is very much damn sure you use SYT for ductile, SUT for brittle. Okay. So I am writing only SYT, but SYT refers to SYT or SUT. And guys, I would also like to tell you that this theory is found to be the best one for ductile material. Okay, this theory is found to be the best one for ductile material. And when we are talking about the failure envelope for Rankine theory, we are going to get a square when we are talking about the failure envelope. And for MSST, we are going to get a hexagon. Okay, so two theories are over. Now we are moving to the third theory. So when we are talking about the third theory, it is nothing but maximum strain energy theory. It was given by Sir Hayes. So it is also known as the Hayes theory. So when we are talking about the Hayes theory, you should understand here the concept was the failure is happening because of maximum strain energy per unit volume. Okay. हाँ, obviously maximum ही लेना है. सुनो आश्रय एक बात. When I am writing sigma 1 and sigma 2, it simply means maximum of these two. Okay, so it simply means maximum of these two. Okay, so guys, do like and share the session. When we are talking about maximum strain energy theory, for that the expressions are coming for strain energy per unit volume. that is coming out to be strain energy per unit volume. So strain energy per unit volume is represented by U, small u. It is also written as capital U by volume. It is coming out to be 1 by 2E. This is I am writing because of combined loading. That is going to be sigma 1 ka square plus sigma 2 ka square plus sigma 3 ka square minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. Why I am writing this formula? Because it have been asked in paper many times. But if you are talking about the statement is coming out to be sigma 1 ka square plus sigma 2 ka square minus sigma 1 sigma 2 is less than equals to SYT square upon N ka square. If you talk about this theory of failure, the failure envelope is coming out to be a generalized ellipse. Okay, a generalized ellipse. It is having semi-minor and semi-major axis. So when we are talking about semi-major and semi-minor axis of the ellipse, then my dear, the formula is for that as SYT divided by square root of 1 minus mu, and here it is coming out to be SYT divided by 1 plus mu. But the point is, this theory is neither found to be applicable for ductile nor for brittle material. So it failed for all the types of material. That is why this theory is not used generally. So guys, next we are talking about the fourth theory of failure. Fourth theory of failure is maximum distortion energy theory. It was given by von Mises. So it is also known as von Mises theory of failure. So when we are talking about von Mises, it is a clear modification of the previous theory, and he said the failure is happening because of shear strain energy. So he have defined the distortion energy per unit volume as the failure criteria, which was given as 1 plus mu upon 3E. All these things we have derived in the classes. It is sigma 1 ka square plus sigma 2 ka square plus sigma 3 ka square minus. Okay, previously I feel I have written something wrong. Minus 2 mu will also come. Minus 2 mu will also come. Sorry for that. So minus 2 mu will be coming. Okay. And when we are talking about UD, here it will be coming minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. I was thinking nobody told about that as well. Nobody told about that. Yes, please tell me, is it clear or not? अरे बोलो भाई, याद आया कि नहीं? याद आया कि नहीं? Everybody, अरे याद आया कि नहीं? MSET में we are having minus 2 mu times sigma 1 sigma 2, whereas here we have no minus 2 mu. That is why semi major or semi minor में भी 2 mu आया था. Okay, this is the formula for distortion energy per unit volume. And when we are going to write it, it is going to be sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is less than equals to SYT square upon N square. And this time also you would be getting a generalized ellipse. This time also you would be getting a generalized ellipse. And this time, whatever generalized ellipse is coming, there is a different. This time semi-major. Semi-major is nothing but root 2 SYT. And when we are talking about semi-minor axis, you can write root 2 by 3 SYT. Is it clear for everyone? Yes. So this is going to be the formula for MDET, von Mises theory of failure. Very good, Vidyarthi. So guys, this is about MDET. Okay. And now my dear, if you are talking about this is found to be valid for ductile material. Okay. If you are going to compare MSST and MDET, then you know MSST and MDET is having a difference, that when we are talking about MSST and MDET, both are utilized for the ductile materials. So when we want to compare both of them, I would like to say one thing, that MSST is said to be the safest. It is said to be the safest but uneconomic theory of failure. Uneconomical theory of failure. But whenever we are talking about MDET, it is found to be not safest but safe, including the economical. But the point is, when we need to use which theory of failure. So I would like to say, if in the question you are clearly mentioned that the material is brittle, then without thinking anything, you would be going for maximum principal stress theory. And if the material given is ductile and they are not saying which theory to use, then guys, you would be going for MSST, because if examiner is not saying anything, we will be giving preference to the safety rather than economy. Is it clear? Please tell me. Yes, yes, yes. So this is the very important point which you need to take care, that you need to follow if nothing is mentioned. If nothing is mentioned, then you have to follow this. If nothing is mentioned, then you have to follow this. Is it clear for everyone? Yes, guys. So guys, we are moving further now. Now the last theory is maximum principal strain theory. So when we are talking about this maximum principal strain theory, it was given by Saint Venant. It was given by Saint Venant. So we are also calling it as Saint Venant theory of failure. And for Saint Venant theory of failure, when you are talking about, it is coming out to be sigma 1 minus mu times sigma 2, or sigma 2 minus mu times sigma 1, that is less than equals to SYT divided by N. And when we are saying this theory of failure, the failure envelope is coming out to be rhombus. Okay, it is coming out to be rhombus. And this is also neither valid for ductile nor for brittle. It is neither found to be valid, neither for ductile nor for brittle. Okay, nor for brittle, because its failure envelope is very, very big. Even MSET failure envelope is lying inside its failure envelope. So this is not going to be important for examination point of view. Okay, so now we are having the next topic, fatigue loading. Here I would just like to tell you the relation between the tau and sigma. If you want to find out, then I would like to say, whenever you are going to write tau, it is going to be point, or you can say SYS rather than tau. SYS is equals to 0.5 times of SYT as per MSST. Sometimes they are asking these two theories. It is going to be 0.577 times of SYT if it is going to be as per the maximum distortion energy theory. These two things also you need to take care. So here, as I said, we are going as per the formula revision session. So I am going only for the important formulas. I am not going into all the details, because for that I have already taught you in the marathon. So this is the time just to see the important things which we are having the formulas for. Now the next topic is fatigue loading. So when we are talking about the fatigue loading, the very first formula, or whenever we are defining, is the mean value of stress. So mean value of stress is defined as maximum plus minimum value of stress divided by 2. Then we are having amplitude of variable stress. It is defined as sigma maximum minus minimum by 2. Okay, we are going to have this sigma maximum minus minimum by 2. And whenever we are talking about sigma mean, sigma amplitude, after that we are having the stress ratio. Okay, it is defined as the stress ratio. So these are the understood things. Here I am writing stress ratio. So it is defined as sigma minimum by sigma maximum. Similarly, we have something called as amplitude ratio. So you need to understand that amplitude ratio, as the name is amplitude, amplitude will be coming in numerator, mean will be coming in the denominator. Then we are going to have the range of stress. Range of stress, when we are talking about, we can denote it by RA. So RA is sigma max minus sigma mean. Sigma max minus sigma mean. I feel I have given you all the formulas whenever we are talking about the terminology of fatigue loading. Okay. Then my dear, you are also having a formula of maximum value of stress, that is defined as the theoretical stress concentration factor into the nominal value of stress. Okay, where nominal value of stress is defined as load but a minimum area. This is defined as per the strength of material. So this is the maximum stress as per the strength of material. Okay, KT is the theoretical stress concentration factor. This is theoretical stress concentration factor. Theoretical stress concentration factor. Okay, theoretical stress concentration factor. After that, my dear, I would like to tell you that whenever we are going for the endurance limit, that is coming from where? That is coming from the famous SN diagram. But you know, when we are talking about SN diagram, we are starting it like this. It is going to be like this for mild steel. Okay, I am making it for mild steel. And everybody is aware that it is made on the log base. So it is 6, it is 3. On the x-axis we have log base 10n, where n is the number of revolution before first fatigue crack. And here we have log base 10 amplitude stress. Okay, this is the diagram about. This is defined as log base 10 it is 0.9 times of, sorry, it is 0.9 times of SUT, and it is going to be what? It is going to be log, sorry, I feel I have written slightly wrong. This is not 0.9 times, this is whenever we are going to have SUT, this is going to be log base 10, 0.9 times of SUT, and this is defined as log base 10 SC, and this is going to be the SUT, this is going to be the SUT. So log base 10 SUT, because that ultimate stress, the material will be failing without anything, okay, without any loading, without any revolution, sorry, when you are going to apply the stress more than ultimate stress without any revolution, the material or the component will fail. Okay, very good, Shreyas. So you know that generally we are talking about this as low cycle fatigue, है ना, low cycle fatigue, and this is going to be high cycle fatigue. Okay, high cycle fatigue. So you know we are generally going to use the high cycle fatigue. And how to do the question for that? Everybody know that if the question is coming that this is given to you, this is given to you, and this is also given to you, they are asking you for this value of stress, what would be the life? So for that you are saying this is triangle ABC and the triangle ADE. You are taking the similarity, you are writing AB by BC, and that is equals to AD by DE. When you are using this, you can get the unknown. Let us say this is X, so you are going to get the value of X. X is nothing but log base 10n. So your answer for the life is going to be number of revolution as 10 ki power X. So this you can do. Now my dear, whatever from this diagram you get, that is said to be the endurance limit. That is SC as endurance limit or endurance strength. Endurance limit or endurance strength is that value of stress which a material can withstand, for infinite life. Means material will never fail if your stresses induced in the body is less than endurance limit. Actually that infinite refers to 10 to the power 6 cycles. Then my dear, that is corrected endurance stress. Corrected endurance strength is written as Ka, Kb, Kc, Kd into endurance limit. So here SE stress, SE star is the corrected one. Okay, this is the corrected endurance limit. Okay, Ka is the surface finish factor. Surface finish factor. Then you know that these factors, if they are given, use the value, not given, take them 1. Kb is the size factor. You need not to remember their values. Then you know Kc is reliability factor. Kc is reliability factor. Then you know whenever we are talking about Kd, Kd is defined as 1 by Kf. Here Kd is the factor that refers to the actual stress concentration factor, and Kf is nothing but the actual stress concentration factor. It is the actual stress concentration factor. Whenever we are talking about the next term is the notch sensitivity factor. So notch sensitivity factor is defined as Kf minus 1 by Kt minus 1. Here Kf is the actual stress concentration factor, Kt is the theoretical stress concentration factor. You also know the value of Q lies between 0 to 1. Okay, it is lying between 0 to 1. So when you are going to consider Q as lying between 0 to 1, you will be getting that Kf is going to vary between 1 to Kt. So as you know, Kt is the maximum value of Kf. That's why we are going to use Kt for the questions, Kt for the design. And I would also like to tell you, if you are not given SC, then SC can be utilized as 0.5 times of SUT for steels. Many times you will find that you have to use this in the questions, specifically not in GATE, but for other exams it have been seen, already asked in the papers. So guys, now we are moving to the next part. Before we go to the shaft, there is one more thing I would like to write, that is Soderberg equation. So when we are talking about the Soderberg equation is sigma mean by SYT plus sigma amplitude by endurance limit is equals to 1 by N. This is the Soderberg equation. Then we have Goodman line. So when we are talking about the Goodman line, it is defined as sigma mean by SUT, and it is going to be sigma amplitude by SC. It is defined as 1 by N. Then if you want to talk about the Gerber equation, so Gerber equation is nothing but sigma mean by SUT ka square and then we are going to have plus sigma amplitude by endurance limit, and you can say it is not 1 by n, but here you would be having n square here and here, because you know from where factor of safety is coming, when you are putting SYT as SYT by n, when you are getting SUT as SUT by n, and these equations are coming from the fatigue diagram. Fatigue diagram is made between the amplitude stress and the mean value of stress. And when you are going to make this wonderful fatigue diagram, you also know one thing, guys, that there is an equation like this, this is the endurance limit, this is SYT, this is SUT. So here you can see area is very less in the Soderberg. That's why Soderberg is said to be the most conservative criteria. This is similar to MSST. When we are talking about MSST theory of failure, that is also said to be the most conservative theory of failure. Conservative means which is having smaller limits. Okay. So guys, parabola would be coming like this. Everybody understood? This is for Soderberg. This is for Goodman. This is for Gerber. And last I would be telling you, last but not the least, is cumulative fatigue failure. I feel everybody is getting this now. Everybody is getting this. The last one is the cumulative fatigue failure. What was the name of cumulative fatigue failure? Who have given this formula for cumulative fatigue failure? Who have given the formula for cumulative fatigue failure, which is nothing but small n1 by capital N1 plus small n2 by capital N2 plus small n3 by capital N3 is equals to 1. Then if we know the real life, n1 is alpha 1n, n2 is alpha 2n, n3 is alpha 3n. If we are writing with this, you can also write the equation alpha 1 by n1, where alpha 1, alpha 2 and alpha 3 are the fraction of the life, fraction of the total life. So we can write it as 1 by n. This is the second equation. I feel everybody is aware this was given by Sir Minors. So we also write it as Minors rule. So with this, my dear, we have completed the fatigue loading. So we are writing only the formula, guys, okay, as this is the formula revision series. Okay, I feel everybody is getting. So guys, I am just reminding you, tomorrow you can join me for the practice session for mathematics, 26 January. And even I am planning to take the eigenvalue and eigenvectors session on YouTube tomorrow. If you guys would be ready, we can plan it in the evening of 26th of January. Okay, so be ready. Tomorrow morning you may get that you can say link of the session. So here now, my dear, what we will be doing after this, what we are going to do is the shaft. So when we are talking about the shaft, in this there are two formulas majorly. One is related to equivalent bending moment, other is related to equivalent twisting moment. So equivalent twisting moment is more important. It is given as m square plus t square. Basically we are talking about a shaft which is subjected to combined bending and torsion. So bending moment and twisting moment both are acting. So then we are going to have the equivalent twisting moment like this and equivalent bending moment as 1 by 2 m plus square root of m square plus t square. This is the equivalent bending moment. Very good, Faninder. So if you are given KT and Km as the shock and fatigue factor, in that case you can write equivalent torque as equals to KB m ka square plus KT T ka square. So if impact and shock factors are given, we will be multiplying Km with the m, KT with the T. Okay, so this is how we can do with the shaft. The next is bearing. So you know that there are three types of bearing. We have seen the very first type of bearing is axial load bearing. And when we are talking about the axial load bearing, in that we were talking about the pivot and collar bearing. And majorly you may be saying, sir, these are not in our syllabus. You are correct, but we are studying this because of clutches, because clutch also uses the same theory. So you would be knowing that we were having two theories, UPT and UWT. UPT is uniform pressure theory, UWT is uniform wear theory. So when we are talking about UPT, we are saying pressure is constant. When we are saying UWT, we are saying pressure into radius ka product is constant. Okay, here we are saying wear is constant. So you know that when we are using UPT, we were having the first formula as the frictional torque, that is given as 2 by 3, that is mu times W. Okay, everybody would be remembering 2 by 3 mu W R naught cube minus Ri cube by R naught square minus Ri square. This is the first formula we are having. And here we are having TF as 1 by 2 mu W R naught plus Ri. This is the formula for frictional torque. Then my dear, second formula you can write W here is pressure into pi by 4. That is going to be, or not pi by 4. If you want to write radius, then you can write pi R naught square minus Ri square. Okay. So here my dear, the point is not like that. Here W can be written as 2 pi PR R naught minus Ri. So based on that we can define two pressures. Pressure will be maximum if you are writing W as 2 pi Ri into R naught minus Ri, and we would be having pressure would be minimum when you are taking the maximum radius. You know, outer radius is the maximum, R naught minus Ri. Okay, and you also know here pressure is constant, so that constant pressure can be written as W by pi R naught square minus Ri square. Okay, these are the basic formulas which we are going to use in UPT and UWT. So you know, for bearing, if nothing is mentioned, for bearing and new clutches, if nothing is mentioned for bearing and new clutches, we used UPT, and for old and worn out clutches, we use UWT, that is uniform wear theory. I feel everybody is happy with this. On one slide you have seen all the formulas of UPT and UWT. Okay, this is about the first type of bearing. Then we were having the second type of bearing as journal bearing. And in the journal bearing, we were having the first important formula related to bearing characteristic number. So if you remember, bearing characteristic number can be written as Zn by P. Here Z is the viscosity of the lubricant and is the revolution in per second. So I am writing here Z is the viscosity of lubricant, and we are having N as the speed of the shaft in revolution per second. Pressure is having a unit of Newton per meter square. So always remember about the units here. This is bearing characteristic number, first formula. Second formula you were having about the Sommerfeld number. Sommerfeld number is defined as Zn by P and then D by C ka square. Here Zn and P are the same. What is D? D is dia of journal. Journal means shaft. Okay. Which shaft? Which is inside the bearing. And C is diametral clearance. And I feel everybody know that we can also write Sommerfeld number as Zn by P into R by C1 ka whole square, because D by C and R by C1 are same, because C is 2 times C1, where C1 is radial clearance. Is it clear? Everybody got it? Then my dear, you also know we have defined a case of hydrodynamic journal bearing. When we are talking about this case, this is the bearing and we are having this as the journal in this condition. And you know, if this is the journal, we are going to have minimum oil film thickness like this. This is H0. Then if you remember, you know, bearing is at rest, shaft is moving, and in between we are having some lubricant. So if you remember, when we have studied this case, we have assumed that there are two plates. One plate is fixed plate, other plate is moving plate. So we have taken this part in the zoom way. Okay, so this is h naught. Okay, this is h naught. This is moving with the velocity pi d n, and you know velocity is varying linearly like the fluid mechanics we know. We assume tau is equals to mu times du by dy. So we would be writing tau as z times u by y. Here is h naught. This h naught will be C1 for radial clearance if it is hydrostatic. For hydrodynamic it is h naught, for hydrostatic it is C1. Then my dear, you can also write it as z into pi d n by h naught. If you want to write the shear force, it is shear stress into area. So you know area is nothing but pi d L. Okay, here L is the length of bearing. Length of bearing or journal, because journal is that part of shaft which is inside the bearing. Okay, journal, not shaft. This is the shear force. Then what is the torque? Torque is nothing but shear force into diameter by 2. Then power loss, if somebody is asking you, it is nothing but torque into omega. You can also write torque as it is 2 pi n by 60. If RPM you are going to write, here n is in revolution per minute. I feel everybody understood. Now we are having one more formula for coefficient of friction. If you remember the coefficient of friction, so coefficient of friction can be written as 2 pi square Zn by P into R by C1. Okay, this was Petrov equation. Then we also have Mackie have said 2.006 pi square Zn by P R by C1 plus K. Here K is leakage factor. If leakage factor is not given, take it as 0. And this is nothing but the Mackie's equation or Mackie's investigation. Okay, I feel everybody understood the formula for journal bearing. Now at the last we have nothing but the third type of bearing, that is rolling contact bearings. Rolling contact bearings, which is the most important one. Rolling contact bearings. Actually in rolling contact bearing or ball bearing we have only formulas, nothing more than that is there. So when we are talking about this rolling contact bearing, if you remember the very first formula we were having here, first of all is the equivalent radial load. That can be written as XVFR plus YFA into S. Here X is the radial load factor. X is the radial load factor. Radial load factor. And then we are talking about V. V is the race rotation factor. Race rotation factor. X would be given to you. V is 1 or V is 1.2. If inner race rotates, V is 1. If outer race rotates, V is 1.2. FR is nothing but radial load. Radial load. Then Y is axial load factor. Axial load factor. FA is axial load. Then S is the service factor. S is the service factor. So guys, when we have this formula for equivalent radial load, this is valid if speed is constant. Okay, if speed is constant, then we can use this formula. But you know, if speed is not constant, okay, just wait. I need to add some 2-3 new slides. So when we are talking about if speed is not constant, we have cubic mean load. And cubic mean load is defined as PE, cubic mean load. it is, you know, we have small n1 PE1 का क्यूब, n2 PE2 का क्यूब, n3 PE3 का क्यूब divided by n1 plus n2 plus n3 to the power 1 by 3. This is the case if we are having the speed is changing. Let us say this is time t1, this is time t2, this is time t3. So we have these 3 time intervals, and in these 3 time intervals we are going to have, let us say here, this is the radial load, this is the axial load, this is the value of FR1, this is the value of FA1, and speed here is n1. Then small n1 is the number of revolution which is defined as speed into time. Similarly here, let us say this is the FR2, this is the FA2, and speed here is n2. So small n2 is defined as n2 t2. Let us say here FR3 is this, F axial is not there, speed is n3, so n3 is n3 t3. And you know that from this FR1, FA1, FR2, FA2, FR3, you can use the formula of this and you can find out PE1, PE2 and PE3. After that you would be getting this. Now we are talking about the rated life. So if we want to find out the rated life in millions of revolution, then my dear, let us say in hours it is given to you. You would be multiplying it with 60 to convert it into minutes. You would be multiplying it with the RPM so that you can convert it into revolution. You would be dividing it to 10 to the power 6 so that you get the life in millions of revolution. So you know what is the meaning of rated life. If you want to find out rated life for some other reliability, let us say you want to find out L60, then the ratio of L60 by L90 is defined as Ln 1 by 0.6 to the ratio of Ln 1 by 0.9. It is going to be to the power 1 by 1.17. So this is how we can get the ratio, and you can also find out with the same formula L50 as 5 times of L90. So I would like to say L90 is said to be the rated life, L50 is said to be the average life. And at the last you are also having a load life relationship, that is this is going to be C by P is equals to L90, and L90 to the power 1 by K. Is it clear? And you know the value of K is nothing but 3 if it is ball bearing. Value of K is 10 by 3 if it is a roller bearing. Please tell me everybody understood this or not. So in this last 40 minutes we have done the formula for many topics. We are left with very few ones now. Only joints, gears are left now. Is it clear for everyone? And in joints, you know, there are not much formulas. Is it clear? If anywhere you find I am doing any mistake, you can rectify me at that time. Okay, very good guys. So now we are talking about the joints. So my dear, in the joints, we are having the reverted joints first of all. So when we are talking about the reverted joints, so the formulas are very limited. You have, let us say, a plate like this. First of all, we are having the formula for, let us say, there is a plate where loading is not eccentric, but load is passing through the centroid of the rivets. For such case, I feel everybody know that the tearing strength of the plate is W minus 3DH. 3 is the number of holes and W is the width of plate, into thickness, into sigma T permissible, and this is for the plate material. And when we are talking about the shear or crushing strength, it is for the rivets. So this is for plate, shearing and crushing is for rivet. So PS is N into pi by 4 dr ka square into tau permissible. Here this is the total number of rivets. Total number of rivets. Okay, and this is the holes. This 3 is the number of hole. Number of hole or rivet in a single row. So in a single row, that is the difference. Similarly, you can write the crushing. It is N into dr into T into sigma crushing permissible. You remember that this sigma crushing and tau permissible is for the rivet material. That is the difference, because these two are the rivets failure. Above one is the failure of the plate. Now my dear, I would also like to add here the strength of the joint. Strength of joint. It is defined as the minimum of 3 PT, PCR, PS. This is the strength of joint. What is the efficiency of joint? It is defined as the minimum of PT, PCR, PS. This is the strength of joint divided by the strength of unriveted plate, where strength of unriveted plate is written as W into T into sigma T permissible. And guys, when we are going for the per unit pitch length, the efficiency formula is coming out to be 1 minus DH by pitch. This is the efficiency of a riveted joint when we are going for per unit pitch length. Per unit pitch length. What is the per unit pitch length? When you are going for the per unit pitch length, we are thinking for the one pitch distance only. We are not talking about the total width. We are talking about this much distance only. So when we are talking about this much distance, in that case the unriveted plate will be having a strength of P into T into sigma T permissible. And when we are going to find out PT, it would be nothing but P minus DH into T into sigma T permissible. So when you would be taking the ratio of these two, you would be getting this. This is a very important formula from which 2-3 questions have already been asked. Is it clear for everyone? Ha, Someshwar, is there any problem with that? Is there any problem with that? Do you want to again postpone it after exam? Arey bhai, in production, I feel if you are facing difficulty in any part, like I have taken casting welding, I have taken material science. Those topics which I have not taken, past years marathons are available if you want to go for detail. Okay, so don't worry about that. Okay, you want on 26? क्या करूं भाई 26 को? मैथ्स भी पढ़ना है? या तो कैलकुलस छोड़ के प्रोडक्शन पढ़ा देता हूं आपको. सारी चीजें कैसे करूं बताइए. Okay, so हाँ, for in the notes I will share for sure. Notes I will share for sure. Okay, don't worry. So guys, now let us move further. Now let us move further. Now let us move further. हाँ फनिंदर, 3 इंपॉर्टेंट टॉपिक है अगर आप बात करेंगे सिम में. एक तो जी एंड एम कोड पढ़ लो, एक बेसिक लेंथ यूनिट कर लो और एक ज्योमेट्रिकल ट्रांसफॉर्मेशन कर लो. ये 3 चीजें कर लो, काफी है. ठीक है, और मैं नोट्स भी शेयर कर दूंगा और इवन मैंने 1-2 बार पीडीएफ भी शेयर करी है जो क्लासरूम की है. ठीक है, तो नोट्स में शेयर कर दूंगा. नोट्स में आपको इंपॉर्टेंट टॉपिक ही शेयर करूंगा, सारे पढ़ के क्या करोगे फिर. ठीक है, आई विल शेयर इट, डोंट वरी. Okay, I am looking if somewhere in between I get the time, I go for revision of metal cutting and metal forming. I am planning for that, but the problem is as mathematics is also going on, app also going on, so in between it is very difficult to get the time. That is the problem. Okay, so guys, but I feel you can also refer the recordings of the previous years available, है ना? So go for that rather than waiting for that. This is PT P minus DH because I tried to give you maximum whatever possible from my side. Okay, अब तो बस यही है कि मैं रात को भी ना सोकर आपको रात को भी एक सेशन ले लूं. है ना? So I am trying my level best. If possible, I will surely take. But you can see as continuous schedule is going on. We are meeting every day almost on the YouTube. So guys, now we are talking about this. And I would also like to say thanks also to you that you guys have shown that much love and support for me. That is why it is possible for me to take. Otherwise, you will not find any person taking that much thing on YouTube. That is just because of your love and support, the way you have shown. It is really wonderful. You know, this is the bolt. I am not going for eccentric loading because eccentric loading we have seen in detail already. Okay. So when we are talking about this, you know that कि the strength of this part is pi by 4 d square sigma permissible. What about this? You know that this diameter is said to be the core diameter. So pi by 4 dc square is sigma permissible. Here always dc is some k times of d, that would be given to you the relation between dc and d. Okay, rest everything is going to be same. Here I would like to add one more formula, that is for bolt of uniform strength. So when we are talking about bolt of uniform strength, so here eccentric loading, there is no formula that is using the straightaway things. Bolt of uniform strength. So when we are talking about bolt of uniform strength, there are two ways. One is go for external threading, then there is no formula for that. Second is make a hole in the shank. So when we are talking about make a hole in the shank, then they can ask you what would be the diameter of hole to be drilled to make a bolt of uniform strength. Let us say the diameter of hole is dh. So you can write, guys, pi by 4 d square minus dh square, that would be equals to pi by 4 dc ka square. Sigma permissible will get cancelled out and dc would be coming out to be square root of, we need to find out dh. So dh would be coming out to be d square minus dc ka square. So if you know the relation between d and dc, you can very easily do. Is it clear? So guys, everybody remember about eccentric loading. Shall I go for that or I can skip that? If you want, I can go for it, but I feel many times I have taught you the eccentric loading. Can we directly move now? Okay. हाँ, ये PDF अभी मिल जाएगा आश्रय, मैथ वाला भी मिल जाएगा. एक्चुअली व्हेन आई टेक फ्रॉम ऑफिस तब थोड़ा सा डिले होता है, घर से तो मैं आपको साथ साथ प्रोवाइड कर देता हूँ. I have given you differential on the same day. Yes or no? This also you will get just after the session. Don't worry. Okay, so guys, now we are writing the formula for welded joint. That is important, you know that. For that, you know that there are two types of weld. One is fillet weld. For fillet weld, you know the formula is F is equals to 0.707 TL into tau permissible, because fillet welds are weak in torsion, weak in shear. So you know this L is the length, total weld length. It is the total weld length. Total weld length. And then we have second as the butt joint. So when we are talking about the butt joint, for fillet weld also, if you want, I can tell you like this. Let us say this is the force. So this, if this is the weld L1, this is the weld L2, then L will be L1 plus L2. And when we are talking about the butt weld, it is equals to width into thickness into sigma T permissible. Because butt welds are weak in tension. They are weak in shear, weak in shear, weak in tension, weak in tension. Okay, and I would also like to tell you butt welds are look like this. This is the butt weld, and you know here thickness of this is T and width of the plate is W. W is the width of plate. Is it clear for everyone? Yes, it is clear for everyone. This is about the butt weld, and if there is some undercutting, then you know undercutting is going to happen within the thickness. So W into T minus U into sigma T permissible. So these are the formulas. Okay, clear for everyone? Please tell me that. This is about the welded joint. Now we are talking about the gears. So whenever we are talking about the gears, you know, for gears there are two things from where questions are coming. There are two things from which questions are coming. Spring we have already covered with the SOM. Okay, so and I also shared the PDF of SOM taken by me. And you can see there are two things. One is going to be the tangential load, other is going to be the radial load. And this is the net force. And you know this angle is the phi. So you can write Ft as equals to F net cos phi, and you can write F radial as F net sin phi. From here you have also derived that torque is Ft into R. So we can write Ft as T by R. You can write it as 2T by mz. M is the module, Z is the number of teeth. So from here, if you want to find out F net, you would be getting F net as Ft by cos phi. And from here, Fr is Ft tangent phi. Cos phi by sin phi will become, sin phi by cos phi will become tangent phi. Everybody is clear, guys? This is about the first formula. Second formula for gears is the Lewis equation. Lewis equation, you write it as service vector, velocity vector, Ft. This Ft is nothing but 2T by mz. That is going to be less than equals to m b y sigma b permissible. This is the bending strength of teeth material. Y is the Lewis form factor. Lewis form factor or tooth geometry factor. B is the face width. M is the module. Is it clear for everyone, guys? So this is the formula for Lewis equation, okay? And if you want one more formula, I am giving you the wear that I don't remember, so I am writing. This is from data book only. This is dP B K Q. dP is the pitch circle dia. Pitch circle dia. Previous one is the beam strength equation. This is the wear strength equation. So dP is the pitch circle dia, B is the face width. What is K? So when we are talking about K, K is said to be material combination factor. Material combination factor. And when we are talking about K, it is defined as sigma ES ka square sin phi 1 upon EG plus 1 upon EP. Here E is the Young's modulus of pinion and gear divided by 1.4. And at the same time, my dear, you can write Q as the ratio factor. Ratio factor is defined as 2G by G plus minus 1, plus for external gearing minus for internal gearing. So I am writing plus for external gearing minus for internal gearing. Okay, guys, this is about the gears. Now center distance I already told you in tome, that we will see again. Spring is covered in foam. Covered in foam. Okay. One formula was there, Whole factor. 4C minus 1, 4C minus 4 plus 0.615 by C. Here C is the D by D. It is the spring index. Spring index. This formula we have not seen in the strength of material, so I have written this. Then guys, for the clutch we have already seen. When we are talking about the brakes, in the brakes there are two formulas. One is braking torque is mu NR. This is for the shoe brake. Then for the band brake we have T1 by T2 e to the power mu theta, and braking torque is T1 minus T2 into R. These are the formula for band brake. Everybody remember, rest you know we have to take the moments to make the balance things. Please tell me everybody is okay with this. Anything if I am forgetting you can remind me. I can go for that also, but I feel we have covered basics, then theory of failure, then fatigue loading, then clutches, bearings, then brakes, then springs, then shaft, gears, everything is covered. And yes, if you are looking for spring, that is covered in strength of material. And gears part, you have seen this, whatever we have seen here, and rest you will see in the theory of machines, as you know that. Is it clear? So guys, I want to know what you want on priority. I am trying my level best to give you everything, okay? But as you can see, I also have some limitation in which I need to provide you the maximum. The limitation is not for any other thing, but the time is limited, है ना? So as some 24 hours are there in a day, so I'm trying to give you complete for you guys only, but still sometimes it is becoming less when the exam is near. So I hope you guys will appreciate the way I am going for you, because if you see I have taken SOM for you, material science for you, then TOM for you, machine design for you. You will not find any single teacher who is taking that much subjects on YouTube, because if I am teaching you on YouTube, I am confident then only I can teach in front of you na. Otherwise in other way also I can see like okay notes है बगल में मैं पढ़ा रहा हूँ, या तो तुम्हारे सामने खुलम खुला पढ़ा रहा हूँ. Okay, so for that you know a lot more things are required. I'm always ready to give you maximum, don't worry guys, but every time I feel whatever I think to give you, it is always slightly lesser than that. Okay, so I'm happy to see your response guys, really happy. Okay, so guys PDF मैं अभी share कर रहा हूँ. Okay, PDF मैं अभी share कर रहा हूँ, don't worry about that. And I will try कि metal cutting, metal forming, sim अगर कुछ और नहीं तो एटलीस्ट फॉर्मूला तो बढ़िया से रिवाइज आपको मैं करवा ही दूं, ठीक है. आई विल श्योरली ट्राई फॉर दैट. गुड बाय गाइज फॉर दिस पर्टिकुलर सेशन. आई एम शेयरिंग द PDF just at the end of the session, don't worry, just wait 5 minutes and within next 30 minutes you will get the PDF of matrix also. And tomorrow be ready, we would be having the session of eigenvalues and eigenvector in the night. Okay, thanks Faninder. So matrix part would be covered, and then we will be meeting for the calculus, numerical methods, complex numbers, and also for the probability. Okay, so goodbye guys for this particular session. Fine.